Hello everyone. So in this video, we'll learn about Go routines and their life cycle. We will show you very small snippets of code, but don't worry, we'll go through every code in different videos. But just stay with me that what these codes are about to perform, why are they useful? We'll just show you small code snippets, and then in the later halves, we will actually go through every code possible of how you can learn about all these techniques of synchronization and concurrency. Okay, so in this video, let us first talk about a life cycle of a goroutine. In the previous video, if you haven't checked out in this particular series, I have posted about what are goroutines, which in simple terms are very lightweight threads. Okay, now they are actually used to run multiple functions concurrently. So you can make a function run concurrently with other functions by just writing a keyword that is go, and it will start running concurrently with other function calls. So it will create another, you can say, go routine with the main go routine that is running, and then all of them will run in, you can say, concurrently. Now let us talk about the life cycle, and if you have any doubts, you can mention them in the comment box of this particular video. So let's start. So what you can see here is that the life cycle of a go routine in Go involves its creation, execution, and termination. Understanding how go routines are started and terminated is crucial for writing reliable concurrent programs. Okay, so let's see here. Right here. Here is an overview of the Go routine lifecycle and termination in Go. So we'll first talk about Go routines creation. So how is Go routines created? So Go routines, if you have shown the previous video of you can create your first Go routine, the previous video you can check out in this series. That will tell you how you can create a simple Go routine by just writing down the word Go. Okay, so what you can see here is that if you just write down the word go in front of any function call, then that function execution will be running concurrently with the main function call. That is how you can just make and create a go routine. Just writing down go in front of any function call. Now, functions can be, you can say, anonymous functions as well, or you can define it as well. If you define a function with its name, my function, you can call it by just writing down go in front of it, the function call. But if you have written anonymous functions, then you can just write down go in front of those anonymous functions as well. So this is the function call that is it. Don't worry, we'll also go through all the code snippets as well. So these are just two very small code snippets that this is the function call, just write down go in front of it, and that will become, you can say, concurrent. Now that is how you can create a go routine. Okay, this is the part of go routine creation. Now let us talk about go routine execution, how it is actually executed. So it will run in a concurrent manner. Once a go routine is created, it runs concurrently with other go routines. The Go scheduler manages the execution of these go routines. Okay, so remember these terms. Now, Go routines, as you can see, are lightweight threads. Go routines are lightweight threads managed by the Go runtime. They are multiplexed onto a smaller number of OS threads. As I've told you in the very first video in the series, that we have a small number of OS threads, which provides us a limited amount of resource on which thousands of Go routines can be multiplexed, which means that all the Go routines are actually spawned on these less number of OS threads so that we required low number of, you can say, resources, and all of them, because are lightweighted, will be multiplexed on this little amount of OS threads. Okay, now let us talk about termination. So termination. Now we have talked about the creation and the execution. Now how we can terminate these coroutines. Now there are various methods to terminate these coroutines. The first one is the very natural method, like the natural way of terminating coroutine. The coroutine naturally terminates when its function or method completes execution. When the coroutine starts its execution and the function call that we have been invoked as concurrently using this go keyword, if it completes its execution, then naturally it will stop. The main routine will wait for other routines to finish before the program exits. It doesn't always implies, it only implies if we have some sort of a synchronization mechanism, or else if you have also seen in the previous video that the go routine actually ends before the other go routines which are spawned completes. Because if the main go routines closes out, then the other go routines will eventually be closed. Okay, that is one of the, you can say, natural way of termination. The other is explicit termination, which means that you actually wants at a particular time to the other goroutine to be terminated. That can be done by synchronization mechanisms. For synchronization, you require a wait group. And we have a dedicated video for wait group in the next video we will be having for wait group, that will talk about how we can use wait group to synchronize all these goroutines so that one depend upon the other depend upon the other, so that they synchronize and then find out answer. They run concurrently, but they synchronize in the end before terminating. This is one of those very small snippet. Don't worry, we'll go through all of them. So we created a wait group, and whenever we launch, you can say a go routine, we'll add that we have launched a one go routine. And the end, whenever the go routine work is finished, we will mark it that it is done. And before closing the main go routine, we have to wait for it. So this is another go routine that is spawned. It will work, and when it marks that I'm done, then only it will complete, or else the main go routine will wait for it. Okay, that is a very small snippet of what we will be doing in the later videos, but that is how we will be using wait group to wait and to synchronize all the other routines. So this is the other way of termination. The one is natural, this is the explicit one. The other one is closing a channel. So in the next video, we'll talk about channels as well. And channels can also be used for other routines to synchronize and to wait upon each other. So what we can do is that we can close a channel. So that is how a worker can be created. And if a worker closes, then we can assume that the channel is closed, and then we can signal that the channel is closed, which means that there is no synchronization that has to be occurred, then only we should stop. So there are different code snippets, don't worry. I'm just talking about the theory part in this video, just focus on that. You can write down these definitions and what we can do. On these code parts, we'll take different videos altogether. So if a routine is reading from a channel, okay, it can be terminated when a channel is closed. The other thing is timeout and cancellation. So there's a context that is created. If we can create a context like this in Goroutine and pass it via the Goroutine, and what we can do is that instead of closing all these things, what we can do is we can cancel it at any time using this cancel function. So what we have done is that we have created a Goroutine like this, and we have cancelled it using this cancel function provided by the context. Now, what is context? All of that, we have separate videos for that, but don't worry, we'll talk about all of them. But what we can tell is that we can call this function also. That will be provided by context. So context is passed throughout this whole function calls and goroutines. And if we want to close a certain goroutine, we can like cancel it using this cancel function provided by the context. That is one of the other ways as well. And the last way is using the panic. So if we encountered a panic, which means that a goroutine is running and it like hit a condition that is wrong and it is causing a runtime error, so it can also do a panic, and in that panic situation we can like return a panic and like close that goroutines abruptly as well. So panic are not like typically used for normal terminations. It may happen for an exceptional case only. Okay, so if an exception case happen or runtime error happen, then that panic will be invoked and that goroutines will be stopped. Okay. Now, it is important to note that terminating a routine does not necessarily means immediate closure. Okay, let me respond. Immediate cleanup. For example, deferred functions will still be executed. That is one more thing. So we have deferred keyword. Defer functions will still be executed even after the. So if we close a routine, before closing the routine, we have to actually run this defer function. The defer function always run even if the routine is finished. Like if it's terminated, then before terminating, the defer function has to be run. And proper synchronization and resources cleanup should be considered to avoid potential issues. In the end, if we create these channels or routines, we have to also clean up, because otherwise, like it will keep on building and increase your memory or usage. And additionally, routines can communicate their termination status to other routines using channels or other synchronization mechanism. So one routine can talk to other routines using channels, as I told you, we'll talk about in the next video, or wait group. All of these can be used to synchronize these things. And these are the 5 methods actually to terminate. So if we talk about the creation part, we can talk about the execution part, and there are 5 ways to terminate a routine as well. So this is the life cycle of a routine. You can go around it. And don't worry about the code snippets. We have separated dedicated videos. We have a lot of videos lined up to talk about all of them one by one. So if you still have any doubts about the theory part, do mention in the comment box of this particular video. I will tell you and see you in the next one. Till I keep coding, and bye.